Hello learners and welcome to today's session. Today's session is on data warehousing and data mining, which is a part of MCAOL and MCAOL program. And this session we have taken from block 4 unit 11. If you remember, in the last session we actually talked about clustering, where we discussed how the clusterings are going to helpful for different applications of data mining. So we have discussed about what exactly the clustering was, then different applications of clustering application. Then we also saw what do you mean by good clustering. So where we are exactly looking for minimizing the inter-clusters distance and maximizing the intra-cluster distances. Today's session I'm going to talk about what are the major clustering approaches, and especially I will be focusing on partitioning algorithms, which is one of the oldest techniques. I will be talking on k-mean clustering techniques. Also we will talk about how the clusters are going to group two objects or more than two objects into one groups or one clusters. So based on the similarity and dissimilarity of the object, we will try to find out the distance, and based on these distances we will be actually calculating the similarity. And then we will also understand what do you mean by k value, because when we talk about k-mean, k means k defines the number of clusters. So basically it is one of the input where the user has to give how many number of clusters he wants to build. So we will see how the clusterings or how many numbers are going to be defined by the user, because many times the user of the clustering techniques may give the very random numbers, but in research we find that there are many approaches using which one can easily find what should be the value of k. Then we will see the example if possible. So if you remember, clustering basically finds the group of record which are similar in nature, and we have also discussed what is clustering. It's one of the unsupervised clustering techniques, and where no predefined classes are defined. So what we have an input for a system of clustering analysis is a set of samples that measures the similarity between the two samples. Then finally what we are going to get is the output from the clustering analysis. Clustering analysis where it belongs to the number of groups that forms some kind of partition or some kind of structures of the partition from the data sets. So if you look at the screen, there are major clustering approaches starting from partitioning algorithms. Then we have a hierarchical based algorithm, we have a density based techniques, we have a grid based techniques, and we have a model based technique. So if you come to the partitioning algorithm, it basically start constructing the partition by evaluating them by some criteria. Like in our case, we will look at the one of the major or one of the factors like a distance. Then we have a hierarchical algorithms which creates some kind of hierarchical structures, a decomposition of whatever the set of values we have using some criteria. So it also divided into different categories like agglomerative or divisive techniques, where we start with the bottoms up of top down approaches. Then we have a density based. This is also one of the most popular density clustering algorithm, which works on the how dense the two objects are together. Then we have a grid based techniques, which is based on some kind of granularity structures. And finally we have a model based techniques, which is hypothesized for each of the clusters, and the data is to find the best fit for that model to each other. So if you look at the screen again, we have a clustering approaches where we have a hierarchical based techniques, we have a non-hierarchical based techniques. Again, as I said, hierarchical based techniques can be divided into two parts. We have a agglomerative hierarchical clustering techniques, we have divisive techniques, In agglomerative testing, one can actually use the different approaches. We have a linkage methods, we have a variance methods. So basically what exactly we do is based on the how close the two objects are between the clusters. So in case of linkage, we see the shortest one. In case of variance one, we actually look at the average of the clustering points. And in case of centroid method, we actually look the centroid of that particular clusters, and then we try to calculate the clustering techniques. In linkage, again, we have three ways. We have a single approach, we have a complete approach, and then we have an averages approach. But today's discussion actually it's around the partitioning algorithm. The basic concept goes like this. So we need to construct a partition of a data set D of n number of objects into the set of k clusters. So what is given here? Data set is given, n number of objects are also given, and k, we need to give the output as a k number of clusters. So k, we need to find the objects which are actually suitable for that particular cluster. So what we have to do, we have given a k, we need to partition a k cluster that optimizes the chosen partition criteria. So basically there are different techniques. Again, we have a global optimal techniques, exhaustively enumerate all the partition, and based on that partition it optimize the what you call clustering points. Based on the heuristic methods such as k-mean or k-medioid, it actually look at the mean value of that particular clustering points, or we have a k-medioid point, it look at the medioid points here. So if you look at the k-mean partitioning techniques, each cluster is represented by the center of the cluster here. In case of k-medioid, which is actually similar to partitioning around the medioid here. So each cluster is represented by one of the objects in the cluster. So one can start with any clustering points they wish. Then let's start with the k-mean clustering here. So if you look at the k-mean partitioning techniques here, so we need to group the number of clusters based on the whatever the criteria we are looking for, and the condition we need to satisfy is k should be less than n. So what is a k here? K is the number of cluster or number of partition we have. What is n? N is the number of objects which we have or number of sample, one can say, number of items one can say here. And our job is to find some ways so that we can cluster or we can group them into a given number of partitioning. So partitioning methods should have the following characteristics. That means each group must contain at least one object. That is one of the most important characteristics. And each object must belongs to exactly one groups here. So whatever the samples we have, it should be part of one group or one clustering here. And each objects must be belonging to the exactly one group only. Now look at the pseudocode of k-mean clustering techniques here. So we have a k-mean algorithm for partitioning where each k clustering center is represented by the mean value of the object in the cluster. So what is input given? Input is k, that is number of cluster is given. That given in the sense we need to define the number of clusters, and D, that is a data set which contains the n number of objects. And what should be the output of this algorithm? Output will be the set of k cluster having the objects which are similar in nature. So how exactly our machine is going to perform these activities? So the method goes like this. Arbitrarily we need to choose the k objects from the D data set as an initial clustering point, right? So based on the initial clustering centers, what exactly we will do is we will randomly choose the this k value here. And then we need to repeat the following operation here. So we need to, in the beginning, we have to assign each object to the cluster to which the object is most similar. Now one can say how exactly the computer will know how they are similar in nature. So in computer practice, distance is one of the measures using which one can calculate the distance between centroid and that particular object, and based on if the distance is minimal, it will belong to that particular clusters here. So this step is going to be repeated, and every time we have to see that the mean value of that object into the cluster, and every time we need to update the clustering means or clustering values, and we need to calculate the mean value of the object for the each cluster. And this will continue till there is no further change. That means at the end of the algorithms, once we know the number of what should be the number of cluster, that is k, we know that what are the data sets objects we have. So at the end of this algorithm, the output is going to be number of clusters having the objects which belong to that particular clusters. I think we will understand with the help of one example. So let's look, before talking about that example, another important objective of k-mean clustering is to minimize this intra-cluster variance, or sometimes it is also known as squared error function. So basically we have a summation of j is equal to 1 to k. K is number of clusters, and then we have to run from I is equal to 1 to n, that is number of cases, and then we need to find or use the distance function. There are many distance functions available, we will discuss further. And for each distance, what we are going to do is we will be calculating the distance from that objects to both the beans. For example, if you have two clusters defined, so both the clusters will have a mean value or center value. From that center value, you are going to calculate the distance from every single object, and we'll see that whatever the objects having the minimum distance, that particular object will belong to that particular cluster. So basically it measures the averages of the squares of error, and that is the average square difference between the estimated values and the actual values. So at the end we'll see that there will be no change in that intra-cluster variances, and that time we know that our algorithm is set. That means there is no further change in the algorithm. So let's understand this k-means clustering method with the help of an example. Now look at the screen again. So I have taken one small graph here. You can see that we have a different points here, and you can see that what is given here, given the k-means algorithm, which is implemented in the 4 steps here. So what is step number 1? So we need to partition the objects into the k non-empty subset, right? We need to compute the seed point as the centroid of the cluster of the current partition. The centroid is the center or mean point of that particular cluster, or sometimes we call it as the average of that particular cluster. After that, we need to assign each object to the cluster with the nearest seed point. So seed point is something which actually we need to start with. So arbitrarily we are going to choose that seed point value of that particular cluster, and based on that we are going to calculate the distance between that seed point to each and every single object, and see that whatever the objects and centers having the least distance, that will belong to that particular cluster. Then this point will repeat again and again. Now let's choose this arbitrarily the value of k here. So in this case I have chosen 2, k is equal to 2. That means the number of cluster is going to be 2 in this case. So K object as an initial centroid point. As you can see that we have a red dot here. So the total values, you can see that we have a 4, 5, 6, 7, 8, 9, 10. 10 initial point was there, right? Then based on that two arbitrarily chosen seed point, we have started with the arbitrary value of K here, that is shown as a red point here. Now after this, what we are going to do is we are going to assign each and single object to the most similar centers. Now how do we know most similar? Once again I am repeating, it is based on the distance. The distance between that red point to the remaining centroid point we have in this graph. So whatever the distance are having the least one, it will belong to that particular cluster. So now based on this, what exactly you can see that we have taken some seed point here, and based on these seed points we need to update the clustering means here. Once we know that okay, there are points which belongs to either K is equal to 1 or K is equal to 2, that means red 1 or red 2. Now based on that, what we have to do is we have updated the cluster means. That means the clusters is having the new seed point, right? And now from that seed point, you again, because this algorithm repeatedly perform this operation and calculate the values and reassign those values once again. And once again you can see that we have a different points here, and you can see that there is a change in the object where they are actually shifting from first case to second case, then second case to third case. And then finally what we have to do, once again you have to perform the this clustering of the whatever the points we have, and based on this cluster again what exactly you get is you get the new seed point here, and this you again perform as a reassigning here, and this goes and on until you find, you means your system finds that there is no further change, right? So you need to go back to the steps 2 and see that if there is no further change in the system, there is no change in the value of that new centroid point, that means your system is stable now. That means you have found the exact number of clusters you are looking for, clustering with the exact number of objects. Now I was talking about the similarity and dissimilarity between the objects here, and the one measures which I have mentioned is the distances. That means distances are used to measure the similarity or dissimilarity between the two objects. So if you remember in the last session also I have mentioned about the similarity and dissimilarity, because the cluster is going to keep only those items or only those objects which are similar in nature, right? That means in one clusters they are going to keep all the objects which are similar in nature, but at the same time they are dissimilar in nature from that other clusters, right? That is how they are exactly we are looking for. And distances are the most commonly used metrics which we try to use the find the similarity or dissimilarity between these data objects. So most popular one, you can see that Minkowski distance. This is a generic distance formula here, that is distance between the I and j. We have what you call the q, square root of q. Again we have taken the formula that is x j I1 till we have a x to ip here, where you can see that x1, xi2, xip and xj1, x2 are the two-dimensional data objects here, right? And q is basically a positive numbers. So if we define the q is equal to 1, it becomes the Manhattan distance. That is one of the another popular distance metrics. So when it becomes q is equal to 1, that means one can find the distance between the two objects I and j in this case using this formula. So we have a distance I and j one can use mod of xi1 minus xj1 plus mod of xi2 minus xj2 till you cover all the points here, right? So this is how you calculate the distance. And if the q is equal to 2, that means your distance function is Euclidean distance function. That means distance between the two objects d, I and j can be computed using the square root of mod of xi1 minus xj1 of square plus mod of xi2 minus xj2 of square till you cover all the remaining points here. But while using these distance function, there are few properties which has to make sure that your distance function actually follow these properties. So distance between I and j should be greater than equal to 0. Distance between I and I is equal to 0. That means they are both are same. Distance between I and j is same as distance between j and I, and distance of I and j is less than or equal to distance of I and k plus distance of k and j. That means one can also use the weighted distance parametric Pearson product, some kind of moment correlation techniques, or some other dissimilarity measures which also help you to find out the similarity between the two objects here. So I hope you actually understand what exactly I was talking. So if you remember, we have a k-means clustering technique which is talking about how you are going to assign the objects to the different clusters, right? And this is how exactly, and based on these similarity functions like Minkowski, or you have a Manhattan, or you have a Euclidean function, you actually find the minimum distance between that centroid point, and that minimum distance will belong to that particular centroid. Now another question which I have told you in the very beginning was how to find the value of k. Like in this case we said k is equal to 2. What happened if k is equal to 3, right? So definitely everything changes. So there are two most popular methods which can be useful to find the mysterious value of k in k-means here, right? So one is elbow method and another one is Silhouette method here. So in elbow method, as you can see, that we have a sum of squared error, that is k-means clustering SSE versus number of clusters for the two random data set. So if you look at the data set A and data set B, you can actually see that at number of cluster, in this case 3, the first figure, it's showing somewhere in the number of clusters where when it was 3, it started bending, right? It started having some kind of elbow. So that's why we call it this as a elbow method. Then we have a Silhouette method, which is also showing some kind of bend or some kind of tilt between the different clusters here. So again, what exactly we are going to do is we are going to have the sum of squared error, and we see that until it goes to the stable condition, and we know that after that there is no going to be change. So we know that we have found the exact value of k here. So people start with a 2, they start with a 3 and 4 and 5, but in literature, if you really look at, there are techniques like elbow methods or Silhouette method where people have really used these techniques to find the exact number of clustering points. So based on this clustering point, one can always see that how the value of k can be defined here. So if you remember in the previous classes, we talked about there are different applications of this. One of the most popular application which I have told you was if one wants to find the credit card fraud detection, right? So there are customers who are paying EMI on time. So there are few properties of that particular customers which can be recorded, which can be traced back by the banking people, and they can really use to find the number of clusters here. And sometimes you can see that if you really look at this formula here, there are objects, okay, either they belongs to one or uh, two clusters here, right? But sometimes there will be some object which will not be belonging to any of these clusters. That means they are the outlier of that particular system, right? So that is what the credit card fraud detection system actually used to find those systems and all. So this is how exactly we have discussed. So in summary, if you look at, we actually talked about the clustering techniques, though I have already discussed about the clustering techniques in details in the previous session. Today's session we actually talked about one of the most popular clustering techniques, that is a k-mean testing clustering techniques, which uses the different distance-based similarity metrics. Either it could be Minkowski or Manhattan distance or Euclidean distance, and using this one can always form the clusters. One of the major advantage of having this k-means clustering is your data point should be numeric values. So if your data is there in the categorical values, either you should have some way to change back to the numeric values or not. I hope you have understand today's session. We'll meet in the next session again.